Hello. In the last video, you learned about working with appurtenances in infraWizard. By now, you know how to manage the appurtenance library and insert appurtenances into your networks. In this video, I will show you how to create a new appurtenance definition to add it to the appurtenance library. The appurtenance definition file is simply an AutoCAD drawing that contains a set of blocks which define how the appurtenance is represented in the plan, profile, and BIM model. There's a set of ready-made appurtenance definition files available with the installation of infraWizard. These can be found in the infraWizard Projects folder located in the User's Documents folder. Each of these DWG files defines one appurtenance size of a certain appurtenance type. The easiest way to create a new appurtenance definition is to copy one of these files and change its contents. This is what we're going to do right now. I copied the definition file of a 200mm gate valve, and I'm going to use it as a base to create the definition of a 300mm butterfly valve. First, let's take a quick tour of the key parts of this drawing. An appurtenance definition consists of 3 essential blocks and 1 optional block. The first one is called 3D block at pipe. This is the essential block of the appurtenance that will appear in the BIM model. When you export a BIM model, the block insertion point will be exactly on the pipe center line at the valve location, and the block itself will be aligned with the pipe. You should be careful about the orientation of the block here. The block should be created in a way that x-axis direction is the same as the pipe direction. If you select the option Follow Pipe Direction in the appurtenance properties, this direction will match the pipe's start to end direction. But if you select the option Opposite to Pipe Direction, the block will be aligned opposite to the pipe direction. One more thing to care about is that the 3D block must contain one 3D solid object. If you're creating a new appurtenance definition and your source for the 3D block contains several solid objects, you should use the command union to combine them into one 3D solid object. To let infraWizard know that this is the valve's 3D block at pipe, it must be placed on the layer called 3D tie to pipe block. The block next to it here is called 3D block at ground. This is an optional block that will appear in the BIM model too. If it's defined here, it will be placed with its insertion point exactly at the ground surface level, just above the main valve block. For example, it is used here to model the surface box associated with the buried gate valve. Another common use of this block is in fire hydrants. A fire hydrant has a base elbow connected to the pipe. This is the block defined here as the 3D block at pipe. The hydrant barrel itself is defined as the 3D block at ground because the position of the hydrant barrel is always related to the ground level and not the pipe level. This block must be placed on the layer called 3D tie to ground block. The remaining 2 blocks are both essential for the definition of an appurtenance. The first one is the plan block. It will appear in the network plan where you insert the valve. And it has to be on the layer called plan tie to pipe block. The other one is the profile block, which will appear on longitudinal profiles. And it has to be on the layer called profile tie to pipe block. The same rule of appurtenance direction in the 3D block applies to the plan block and the profile block. Now, let's start modifying this drawing to create our new definition of the butterfly valve. I'll first rename the existing blocks in the drawing to make their names refer to the new type and size I'm defining. There's no need to rename the surface box because we're not going to use it in this file. Then I'll start editing the existing block definitions. For the profile block, I will simply stretch the valve symbol equally from top and bottom to make it a bit larger than the nominal diameter of the valve. This will give it the appropriate look on the longitudinal profile. After saving the block, it is important to check that the block insertion point is still at the center of the valve symbol. For the plan block, I'm going to copy the plan drawing of my butterfly valve from the source drawing. Bear in mind that all blocks here are represented in meters for metric units projects and in feet for imperial units projects. Since my source drawing of the valve plan is in millimeters, I'm going to scale it down to be in meters. Before I edit the block, I will scale my symbol again with a scale factor of 2 to make it appear clearer in the network plan. It's up to you to do the same thing or just keep it with its actual size. Since my symbol doesn't have a center mark, I'm going to pin its center to make sure it will coincide with the block insertion point. Now I'm ready to edit the block. I will first add my new symbol to the block. I'll match the format of the new symbol from the old one. This will make the symbol take the same color of its network when inserted in the project. I will then erase the old symbol, but keep the center mark of it. Next, I will move my new symbol to the center of the old symbol. And finally, save changes. Since we're not going to use a surface box with the butterfly valve, I will erase this block. As I mentioned before, the 3D block at ground is an optional block, so our definition file is still readable for infraWizard even if it doesn't contain it. In general, updating the 3D block at ground is done the same way as updating the 3D block at pipe, which I'm going to show you right now. I have here a source drawing that contains a 3D solid for the new butterfly valve, and it is already transformed into meters unit. I will copy the solid object to the Appurtenance definition drawing. Before I insert this solid into the block definition, I should rotate it in 3D to make it oriented with the x-axis parallel to pipe direction and the z-axis perpendicular to it. I can do this in 2 steps. First, rotate it around the x-axis. Then rotate it 90 degrees in the xy plane. Similar to what we did in the plan block, I need to define the center point of this solid, which is going to be the insertion point of the block. This time, we have to do it in 3D. I will first draw a center line along the valve solid. I'll use the Object Snap tool to draw this line between the 2 centers of the outer faces of the valve. I will then pin the midpoint of this line, which is going to be the block insertion point. I'm now ready to update the block definition with a new solid. I'll open the block for editing, add the new solid to it, and match format of the new block from the existing one. I'll then erase the old solid and move the new solid from its center to the insertion point of the block. I will finally save the block and check that the block insertion point is actually coinciding with the midpoint of the valve center line. Our definition file is now ready to be loaded to the Appurtenance library in any infraWizard project. Thanks for watching, and see you soon.